Hello, welcome back to this Network Science project video series by my colleague Anindo and me Akanksha. In the previous video, we saw about the process of data collection, data cleaning, and how to construct correlation matrices from the data. And in this video, we will be talking about network construction. So once we have our correlation matrices, the next step is to construct the network. We could possibly construct an all-to-all weighted network directly from the correlation matrices. But such a visualization is not helpful considering the large number of nodes we have. We therefore need to make a decision and extract more important set of edges from the graph. This is what we have been calling network pruning the whole time. Now the simplest way of doing this is to set a threshold and say that all the edges above this threshold are significant and those below it are not. And here we can imagine that as we lower our threshold, we'll be getting more denser graph. But then the next question is, what is a good threshold? To solve this problem, thresholds are usually chosen by pairing them with other analysis like connectivity, modularity, etc. Now the other end of an all-to-all graph, which I mentioned earlier, is a graph which has just enough links to connect all the nodes but no more, which is what happens in a minimal spanning tree or MST. The MST is a subset of edges which connects all the nodes such that the summation of weights is minimum. It is a very minimalistic representation, also called the backbone of the graph. Now, in order to construct an MST, the first step is to map the correlations to distance, and this is done in such a way that the maximal correlations relate to the lowest distances so that we can construct a minimal and not a maximal spanning tree. Now, once we construct these distances, algorithmically, MST is constructed as follows. We choose a starting node and then we add the link of lowest weight that does not form a loop with the existing network. And then we add the corresponding other node of the edge also. And we repeat this step till all the nodes are covered. Now, the resulting structure has n minus 1 links if you have n nodes in the network and does not have any loops. And more importantly, the structure is independent of the choice of the starting node. Now, another method to construct a reduced network is called the planar maximally filtered graph. Now, here, the idea is to add the edges in the decreasing order of importance such that no two edges intersect except at one point. So overall, when you can visualize this particular graph, you can draw the graph completely on a plane without intersecting any two edges. Now, this construction is freer in the sense that it allows for many more links and thus more interesting structures to arise than what can possibly be done using a minimal spanning tree. Now, in the following slides, we show the MSTs and the planar maximally filtered graph constructed using Pearson correlation matrix and mutual information matrices. The color of the node represents its sector, while the size is proportional to its degree. Now, just by seeing the network, it is not possible to understand all the nitty-gritties of these networks. But one thing we can see for sure is that in this particular graph, there is only one node which has significantly higher degree, while in this case, we can identify multiple of such nodes which have higher degrees. And when consulting with the data, it can be seen that these nodes are not only do they belong to different sectors, but also refer to completely different companies. And a similar thing can be seen when we investigate the planar maximally filtered graphs obtained using the two different metrics. Now, based on this, even though we cannot quantify the extent to which the two maps are different, but we can see that there are some structural differences which the two matrices can say and which appear in the networks. Now, an important consideration is to study the network properties of this graph. To that end, it was possible to run the algorithms, but it is comparatively complicated to make sense of the results, mainly because of the complexity of MST and PMFG. A simple question like, what does a high degree have mean in an MST? Or what does planarity actually get rid of? And all of these questions started to have complicated answers. And although we have made some progress, we did not want to make claims. And so we have left the network analysis of these graphs out of these series. Now, based on the networks that we saw in the previous slides, we can say that there are different nodes which Pearson correlation as well as mutual information identify as significant. But to say that confidently, network analysis is of great interest and also of great importance, but has been left out of this series.